Hey guys, welcome to lesson 5.1.1 day 1. It is the first lesson of second semester and first lesson of chapter 5. So we are today going to talk about what an inverse function is and kind of how to find inverse functions of regular functions. All right, so let's say we have a function right over here, 5x plus 2, or f of x equals 5x plus 2, and I want to describe this function in words. Basically, I'm telling you to tell me what the function does to x. Okay, now you want to follow like an order when you're doing this. So you look at this x and you're like, okay, well, the first thing that happened to that x was that it was multiplied by 5. Okay, we multiplied it by 5. Okay, and then the next thing after x was multiplied by 5 was that we added 2. All right. Okay, so that's pretty much all that happened in this function. So now if we try to undo the function, that means we're kind of unraveling it, right? So whatever happened here, we need to do the opposite. And because we're undoing it, we kind of have to start where we left off, right? Like when you're wrapping a present, at the very end, you put your piece of tape. And so it only makes sense that if I want to unwrap the present, I have to start by taking off that tape, right? So here, if my last step was to add 2, my first step is going to be to do the opposite of adding 2, which is subtracting 2. Okay, and then multiplying by 5, the opposite of that would be dividing by 5. So now, the undoing function, as we are currently calling it, would then be, we're another set of steps that we're doing to x, but now we do it in this sequence. So we take an x and we're going to say, okay, well, for this x, we're going to first subtract 2, and then we're going to divide all of that by 5. So then you just divide those by 5. Right, and that is our undo function. We're going to call that g of x instead of f of x. Okay, that's kind of like another way to write y equals, kind of. It's just a more proper notation. Okay, so this is the undoing function. It's the very opposite of this original one. Using this function, we're going to go ahead and find f of 3, meaning we're going to plug in 3 for x and see what we get. So we'll do 5 times 3. That 3 came from here, and plus 2. So when we calculate this, we get 15 from 5 times 3 plus 2, and we get an answer of 17. Okay, so now the next thing we're going to do is undo everything using the undoing function. So basically, this 17 that we got here, we're going to put that in here, and we're going to plug it in to this equation, or this function that we just got. Okay, so I'll just go ahead and use green for that. So we're going to plug a 17 in for x. In fact, let me rewrite that equation so we know what we're doing here. So instead of x, we're going to write 17, because that's what we're using from the last answer. And we're going to just keep the rest of it the same. So when we calculate this, we get 17 minus 2 is 15, divided by 5, and so we end up with 3. Now the reason I wanted to do this step was to show you that when I plugged in 3 into my original function, I got 17. So when I plug that ending value, that 17, into my opposite, my undoing function, it brought me right back to where I started, which was at a 3. Okay, that's just going to show you how that function truly is undoing the original, because I was able to use that first solution to go back to the original input. All right, so we've been so far calling this like undoing and opposites, but there actually is a proper name for it. And this g of x that we're finding, which is the undoing function, is actually called an inverse function. Okay. Inverse is kind of a fancy way to say opposite. And the whole idea is that an inverse function undoes all of the operations of the original function. So this is the actual correct mathematical word instead of just an undoing function. Okay, and then this is some notation here. So this little -1, that is the notation for the word inverse. You guys might remember from geometry, especially those of you guys that I know I had, that when we did like trig inverses, you know, like sine inverse, cosine inverse, we also had this -1 there. So that still is notation just to mean the word inverse. All right, so let's try some examples here. We're gonna do a couple of different kinds of examples. So for this first one, I didn't give you a function. I gave you the steps, and we're gonna make a function. So based on this, we need to create a function in terms of what we are doing to x. So I like to just start by writing an x because I know that whatever I'm doing, it's going to affect this x directly. So step 1 is to multiply by 3. So I'm going to go ahead and put a 3 up here because that would be multiplying by 3. Now next, I'm going to add 2. So to add 2, I'm going to just do a +2 on the outside here. And to square it, that means I'm squaring the entire thing. So I'm going to take this and go ahead and make some parentheses so I can show that I'm squaring the entire thing that I have written there. Okay, and that's it. We have created our original function. So now to undo the function, I'm going to start at the bottom and go back up, but with opposites. So let's stay true to our colors here. The opposite of squaring, remember to go from the bottom up. The opposite of squaring is square root. The opposite of adding 2 would be to subtract 2. And the opposite of multiplying by 3 would be to divide by 3. All right, so now using this, oh wow, I didn't even stay true to my colors. I'm gonna fix that real quick. All right, we're all fixed. So now we're gonna go ahead and write our inverse function. So let's go ahead and start by writing our x, because we're just gonna, everything that we do, we're gonna do it to x. So just write a little floating x. Step 1, we're gonna square root. So I'm gonna square root this x. Step 2 is to subtract 2. So I'm gonna go ahead and do a -2 here. And then step 3 is to divide by 3. So I'm going to take all of this and just divide it by 3. All right, and that is my entire inverse function. I keep forgetting to write g of x at the beginning. Doesn't matter which side you put it on. All right, and that is it. I found my function. So let's do another one. This time I gave you the original function, but we have to describe it in words. You have to be able to do these from any of these points. So we start by looking at this x. And you're like, okay, what happened to it? So we'll start with the fact that it was multiplied by 2. That's the first change that occurred with that x. Okay? And next, we added 4. So add 4. All right, the next thing that happened is that we took all of that and we raised it to the second power. So we squared it. So we're going to write square. All right, and then lastly, we subtracted 3. Okay, and that's pretty much everything. So now we're going to go ahead and start from the bottom and go up for the undoing. So instead of subtracting 3, we do the opposite, which is to add 3. Instead of squaring, the opposite of squaring is square rooting. So we will square root. Instead of adding 4, we will subtract 4 because that's the opposite. And lastly, because we have multiply by 2 here, the opposite of multiplying is dividing. So we will put divide by 2. All right, we're ready to create our actual function. So here we will just, remember, write our floating x and then start following these steps. So the first thing we want to do is add 3. The next thing we want to do is square root. So I'm going to go ahead and square root whatever I've written so far. Notice how both of those are in the square root. Next, I'm going to subtract by 4, so I'm just going to do a -4 out here. And, oh, that was not the right orange. Okay, there we go. And lastly, we have to divide by 2. So we will go ahead and divide by 2. And once again, I forgot to write g of x. I am terrible. Okay, and that's it. We have made our inverse function. All right, one last example for you guys. And this time, again, I gave you these steps, and we have to make the function. So let's start by writing our floating x. Let's write it here. Okay, so step 1, we are going to add 5. So +5 here. Step 2, divide by 2. So we're going to take this and divide everything by 2. Next, we're going to cube it. So raise it to the 3rd power. So we're going to put parentheses. Anytime you have to like square or cube anything, you got to put parentheses around everything there first so that we know that we're cubing everything. Okay, and the last step is to multiply by 6. So I'm just going to go ahead and put a 6 up here in the front. If you put it on the other side, it would be okay too. But personally, I like to have the multiplication at the front. All right, now let's undo the function. So we're going to start at the bottom and go up. So instead of multiplying by 6, we do the opposite, which is divide by 6. All right, now that we have done that, next will be to do the opposite of cubing. So if we cubed first, the opposite is cube root, just like a square root, but with a 3 instead of a 2. And then now we have to, let's see, opposite of divide by 2. So multiply by 2. And finally, instead of adding 5, we will do the opposite, which is subtract 5. Okay, we have our instructions now, and we just need to follow them to write our function mathematically. So let's do our floating x. And let's see, divide by 6. So divide by 6 means to do this. Cube root. So cube root means we're going to put that like radical, the square root looking thing, but because it's cube and not square, we need a 3 here. That's what it means to cube root. Multiply by 2. So, oh, I should have thought about this, but all right, well, I'll just do this on the outside this time. So times 2. And then subtract 5. Okay, and I feel like I want to put some parentheses here. Okay, I won't put those parentheses, but... All right. So we have our g of x, which is our undoing function, but we really should know them as the inverse function. All right, that is all for today. Go ahead and try the practice problems if you haven't already.